sketch the graph of a function f that satisfies the following conditions. In part A, the conditions are f at 0 equals 4. That means 0, 4 is a point on the graph. Similarly, f2 equals negative 2. So 2, negative 2 is another point. So let's locate them. 0, 4. On the graph here, 0, 4. So the graph passes through this point. Similarly, f2 equals negative 2. So 2, negative 2. 1, 2, negative 2. So graph passes through here. F at 4 equals 1, 4, 1. 4, 1 up. So the graph passes through here as well. So A is done. In part B, we have f prime at 0 equals f prime 2 equals f prime 4 equals 0. So derivative at these x values is 0. And generally when derivative is 0, most of the time it will be either the local max, the top, or local mean, the minimum, like this. Okay, so at x equals 0, 2 and 4 we'll get either this local max or local mean. So let's look at here. So 0 means at x equals 0, local max or mean, and looks like this is the highest point here, so we'll get local max. Okay, we'll check that later, but for now I'll assume this is local max and just draw something like this. And we know that the graph passes through this point, so local max. And at 2, so here is 2 means that's the kind of low point, so local mean for now. Let's make this, we'll complete this later. And max, mean, maybe this is max again at 4. Okay, so 4 means here, so max again. So we will come back to this to check. In part C, we need to satisfy, we are given that the derivative is positive, means the function is increasing. Derivative bigger than 0. Derivative positive means the function is increasing on where? If x is less than 0. Oh, all the way to the left of 0. So here, all the way from left of 0, the function is increasing, it's going up. Or when x is between 2 and 4. So 2 is here and 4 is here. So in this interval, it's also increasing. The function is increasing. So this will be somewhere here. We'll get that in a moment. Okay. In part D, derivative is less than 0 means the function is decreasing. The function is decreasing on 0 to 2. So in between 0 and 2, that's the remaining here. 0 and 2, the function is decreasing, and after here is increasing. Okay, or when x is bigger than 4. Bigger than 4 means all the way here. That's less than 0 means decreasing. Okay, now let's look at here. Look, at 0, left of 0 is increasing, right of 0 is decreasing. So now we can connect this. So decreasing means, sorry, increasing on means like this. We don't have to complete. It's increasing. Then after 0 is decreasing. Look at this red arrow here, decreasing like this. So this is exactly a local maximum. And after 2, okay, it's decreasing up to 2. After 2, again increasing. So it should come all the way to here. Then after this it starts increasing, and now this is local minimum that we suspected earlier, and that's exactly the case, local minimum. And increasing and again decreasing. Look at here, red, so decreasing. Okay, so decreasing means increasing, decreasing, so local max, and it's something like this. So we suspected this being a local max, and that's the case. So we satisfied basically A, B, C increasing, D decreasing. Now we need to check if E also is also satisfied. We basically get the sketch, but we need to see if E is also satisfied. So second derivative is positive, means concave up, something like this type of shape of graph. Concave up on x between 1 and 3. So 1, so let me use different color here. Okay, between 1 and 3 here, it should be like concave up. And that's exactly the case. Okay, we don't have to do anything, it's just concave up. And it says second derivative less than 0 means concave down on when x is less than 1. So less than 1 means here is 1, so less than means all the way is concave down like this, and we have that. Okay, maybe let's make this, it's concave down. Or when x is bigger than 3, after 3 also concave down, and this is concave down. And this is the sketch of a function f that satisfies these three conditions. Okay, final